Exercise 8.2 question number 2. It is given ABCD is a rhombus. Rhombus means it's all the four sides are equal. AB equal to BC equal to CD equal to DA. And P is midpoint of AB, Q is midpoint of BC, R is midpoint of CD, S is midpoint of AD. It is given. And you are asked to prove that this joining the midpoints of sides, we will get a quadrilateral PQRS. And you are asked to prove that this PQRS is a rectangle. Rectangle means, to prove PQRS is a rectangle means we have to prove that it is a parallelogram with equal diagonals. Parallelogram with equal diagonals. So we will join the diagonals. We have to prove that PQRS is a parallelogram and also PQRS is having diagonals equal. Then we will say it is a rectangle. So I'll also join this diagonal AC of the quadrilateral ABCD. Now, first part, you see, I'll take out this triangle ACD. This triangle I am taking out here. So in this triangle ACD, you see, S is midpoint of AD, R is midpoint of BC. So by midpoint theorem, SR must be parallel to AC, and also SR is half of AC. That was our midpoint theorem. So this one I'll mark it equation 1. And again we'll take out this triangle ABC, this part I have taken out here. ABC, this part. So here you see P is midpoint of AB, Q is midpoint of BC. So by midpoint theorem again, PQ must be parallel to AC and PQ is also half of AC by midpoint theorem, and I'll mark it equation 2. Now you see, from equation 1 and 2, you see what we are getting. I'm showing here. From equation 1 we are getting SR parallel to AC, and in equation 2 we are getting PQ also parallel to AC. So SR parallel AC, PQ parallel AC. So SR must be parallel PQ. It is written here. SR parallel to PQ. It is written here. And also SR is half of AC. PQ is also half of AC. It is here. SR is half of AC. PQ half of AC. So right side equal. Again the left side also must be equal. So SR equal to PQ. So what we got, you see, in quadrilateral PQRS we are getting SR equal to PQ, and also SR is parallel to PQ. So what we got, you see, we got one pair of opposite sides. In quadrilateral PQRS we got one pair of opposite sides equal also and parallel also, and hence it is a parallelogram. PQRS is a parallelogram. So this is the first part. We have already proved PQRS is a parallelogram, and now only if we can show diagonals equal. In PQRS diagonals equal, that means PR is equal to SQ, then we can say that it is a rectangle. We have already proved parallelogram because we have a theorem we have a theorem like this: a parallelogram, a quadrilateral having one pair of opposite sides equal and parallel is a parallelogram. So now only we have already proved PQRS is a parallelogram. Now we will only prove that it is a rectangle. That means it has equal diagonals. So you see, so I'll take out now this quadrilateral ABQS, only this part, quadrilateral ABQS, ABQS quadrilateral. What we have, you see, S is midpoint of AD, that then AS is half of AD. Q is midpoint of BC, then BQ is half of BC. So AS is half of AD, BQ is half of BC. We have written here, you see. But AD and BC are sides of quadrilateral. They are equal. That means right sides equal, so left side also must be equal. So AS must be equal to BQ. AS must be equal to BQ. And also AS is in the line of AD, BQ is also in the line of BC, and these two sides are opposite sides of rhombus. They are also parallel. So AS must be parallel to BQ. So what we are getting, you see, in this quadrilateral, we are getting in the quadrilateral ABQS, we are getting this opposite sides pair they are equal and also they are parallel. Therefore, ABQS is a parallelogram. I have written here ABQS is a parallelogram. So if it is a parallelogram, then opposite sides must be equal. So AB must be equal to SQ. AB equal to SQ. I have written here, marking it equation 3. Again, I am taking out this parallelogram, you see. Not parallelogram, quadrilateral. Which quadrilateral? B, P, B, C, R. This part. So in this part, what do we have, you say? P is midpoint of AB. So PB is half of AB. R is midpoint of DC. So RC is half of DC, written here. But AB and CD are equal. They are sides of rhombus. So that means right sides are equal, so left sides also must be equal. So what we are getting? We are getting PB is equal to RC. We have proved PB equal to RC. But PB is again in the line of AB. RC is in the line of DC, and their opposite sides of rhombus, they are parallel. So PB must be parallel to RC also. It is written here. So what we are getting in this quadrilateral? We are getting one pair of sides opposite sides equal and also parallel. So PB, this PBCR is a parallelogram, and if it is a parallelogram, then opposite sides must be equal. So BC must be equal to PR. BC equal to PR. Mark it equation number 4. So what we did, you see, we have proved in this triangle AB equal to SQ, and in this quadrilateral we have proved BC is equal to PR. But BC and AB, they are equal, okay, because opposite the sides of rhombus. So if BC AB equal, then right sides also must be equal. That means SQ is equal to PR. SQ is equal to PR written here. So what we got, you see, we got SQ equal to PR. That means quadrilateral, this quadrilateral PQRS is having diagonals equal, and it is having diagonals equal means it is a rectangle, because already we have proved it is a parallelogram. It is already a parallelogram, and it is also having diagonals equal, and hence it is a rectangle. A parallelogram with diagonals equals is a rectangle, and this is the complete proof.